Okay, welcome to lesson 2 on composite figures. If you have not listened to lesson 1, please go back and do so. If you have, that's perfect because you've already learned how to find the areas. So now we're going to look at areas of a composite figure. So Ms. Sucker, what the heck is a composite figure? Well, a composite figure is a shape that's built from smaller shapes and simpler shapes that we've already dealt with, right? So when you find the area of a composite figure, I like to take 3 different steps. So my step 1 is to break apart the weird looking figure into shapes that I already know how to deal with, right? My step 2 is to find the area of each shape. And then my step 3 is to either add or subtract areas that are areas together to get the total area of the composite figure. So if we take a look at this one here, I'm just going to hide this because we'll need more space. If we take a look at the area or the composite figure here, right, we can break this down into two simpler shapes, right? So what I can do right now is break this right here. And now we only have to deal with 2 simple shapes that we already know how to deal with, right? We know how to deal with a square and we know, we know how to deal with a square and we know how to deal with a rectangle. Okay, so one thing I'm going to do first is I don't necessarily know what this side is yet. So for me to find this side, what I can do is I can say, well, I know that this is 2 feet, right? And I know that this total is 5 feet. So if I know this total is 5 feet, what I would do is I would 5 minus 2, which is going to give me 3. So I know that this is 3 feet. Right? So what my step 1 was to break apart into shapes I know. I've already done it. My step 2 now is to find the area of each of these shapes. So I would go, and sorry if my writing is bad, I'm trying to keep my arm away from the microphone. So my step 1, or I would look at my figure 1, which I know that I'm going to write my knowns and my unknowns. So I know my length for my figure 1 is 3 feet. And I know my width for figure 2, or figure 1, sorry, is also 3 feet, right? And I know that my area equation for this figure is my length times my width. So now I just take the information I know and plug it into here to get my area. So my length is 3 feet, and my width is 3 feet. Therefore, my total is 9 feet squared, right? Because feet times feet is squared. So now I would box that. So then I'm going to take a look at my second figure. So I'm just going to scroll down a little bit. So my second figure is my rectangle, right? And so I know that my rectangle has the same area equation. And so I would need to find my length and my width. So the length of my rectangle, right, is 6 feet, right? 6 feet long. So I have 6 foot here. And then my width, I know, is 2 feet. So I plug that in here. And then I write my area equation equals length times width. And then so my length is 6 feet. My width is 2 feet. Therefore, my total area for this is 12 feet and then squared. Again, don't forget your squared because feet times feet would just be feet squared. Perfect. So I've done step 1, which is break it up into smaller shapes that I know. I've done step 2, which is find the area of each shape that I've broken it up into. So now my step 3 is to add my areas together to get the total area of this figure, right? So I'm going to go, my step 3 would be to get the area total by adding these together. Equals my area of my square plus my area, of my rectangle. Terrible drawings, I know. This is why I'm not in art class. So the area of my square we know is 9 feet squared, right? Plus the area, this one is 12 feet squared. So when I add those together, I get 9 plus 12, which gives me 21 feet squared in total. So that right there is the area of my composite figure. Okay, so we're going to take a look at a couple more examples. So for this example, we have obviously a different looking shape. So I'm asked to determine the area of this window, right? So I'm going to do my 3 steps. So first things first, I'm going to break it apart into shapes that I know. So I know that I can break this into a rectangle, and I know I can break it into, we haven't dealt with semicircles yet, but I can break it into a circle as well, right? So this is half of a circle, so we're going to figure that out in this, like how to deal with that in a second. But I can break this up into a rectangle and a circle. Okay, so those are the ones I'm dealing with. So now I need to find the areas of each of my shapes. So my first area, right, I'm going to do my area of my rectangle. Right, and the area of a rectangle is always my length times my width. Right, so I'm just going to put this a little 1 here, and this is what I'm dealing with. So my length, right, I always put my knowns and my unknowns. My length is 0.7 meters. So I go 0.7 meters. And my width is my 1.2 meters. And my area, I don't know about. So area can be a question mark. If I really wanted to write that, I could be area equals question mark. Okay, perfect. So now what I'm going to do is I'm going to plug the information I have into my equation, right? So I'm going to go, and I'm just going to put an arrow over here to say that that's what I'm doing. So my area equals, and then length times width. So length is 0.7 meters times my width, which is 1.2 meters. Right? So 0.7 times 1.2 is going to give me 2 seconds here. So 0.7 times 1.2 gives me 0.84. So oh, that was a terrible 0. I'm really trying hard not to muffle the speaker because this is my second time redoing this one. So I apologize if my writing is absolutely terrible. Okay, so 0.84 meters squared. Perfect. And then I'm going to box it because I always box my answers, right? Awesome. So now I need to find the area of my circle or semicircle. So I would go number 2. I'm just going to do it in a different color so it's easier to see. I like green. So the area of my circle or semicircle, right? So we'll just do the area of a circle for now because we do want half of it. So what we're going to do is find the area of a full circle and then divide it by 2. Right, so the area, and I guess I should maybe draw of my semicircle. So the area of a circle is always pi r squared, right? But because we are only using half of it, I'm going to divide this whole thing by 2. Now, on a side note, we need to figure out what my radius is, right? And so the radius of a circle is always from the center of the circle to the outer spot of the circle, to the perimeter of the circle. So we need to know what half of this is, right? We know what the full length is. The full length is 0.7 meters. So half of that would be 0.7 divided by 2, right? Which gives me 0.35 meters, okay? So that is my radius, right? Radius. So that's what my R is. So I would then put my R equals 0.35 meters. So I can now plug my information into my area equation. So my area equation, I just want to make sure I'm away from the, is area equals my lovely pi symbol, and put my 0.35 meters for my radius, square it, and then divide that by 2. Perfect. So then what I do first, remember, is bed mass. So I would always do 0.35 meters squared before I think about doing anything else. So then I get pi, and then 0.35 squared gives me, just get my calculator, 0.35 squared gives me 0.123 divided by 2. And then I would do the multiplication on the top, so times pi, and then divide by 2, which gives me 0.192. Perfect. So 0.192, and this is also still in meters squared, right? Because area is always either, it's whatever unit squared. Perfect. Okay. So I've done my step 1. I broke my figure apart into different shapes that I know how to work with, right? I found the area of both of my shapes. Now, what I have to do is I have to add these two together, right? I have to add them together to get the total area of this funny looking figure. So go back to that, extend the page. That was a lot. So my step 3 is to add them together. So I can't remember what was up here. So my area total equals the area of my rectangle plus the area of my semicircle. That was terrible, but you understand what I mean. So the area total, right, equals the area of my square, which was, oh my goodness, I literally just looked at it, 0.84 meters squared, so 0.84. I can't draw or write, being so careful with trying to not muffle the speaker. 84 meters squared plus 0.192 meters squared, which gives me, if I add those two together, I get 1.03 2 meters squared. And that right there is the total area of my composite figure. Okay, so step 1, we broke it apart. Step 2, we found the area of each different shape. Step 3, we added the areas together to get my total area. Now we have one more thing to go through. This has a lot of steps, and I apologize in advance. So first things first, we're still going to take the same steps we just did. Okay, so the same steps we just did is, ignore this. Yeah, no, it's fine. Is we're going to break it apart. Sorry, I'm falling off my chair because I'm sitting on a Bosu ball. So we're going to break it apart into shapes that we know, right? And right now, this has already actually been broken up into shapes we know for us, right? So we have a big rectangle here. We have 2 little rectangles here, and that's perfect. So what is this question asking us to do? So Turf Tech Lawn Care Services charges 2 cents per meter squared for lawn mowing. So how much would it cost to mow the following lawn? And we have the measurements of the house and we have the measurements of the garden, right? So we're looking for the area of this green spot here, right? All of this, the green grass in this yard. Oh, I'm knocking things. So what do we have to do, right? We have to figure out what this big rectangle is area-wise and what these little rectangles are, okay? So first things first is I'm going to find out my big rectangle. And what I should have said at the very beginning is there's 2 ways to do this. Because this is in meters squared and these are in feet, what you can do is you can change everything into meters first and then do the calculations. What we're going to do and why I have this in here, right here, is we are going to do the conversions after, okay? So that's the approach that I'm going to take because it's a little bit less work, okay? So first things first that we are going to do, we broke it apart into shapes we already know. So now we're going to start with a big rectangle. So I'm going to go where I have my number 1, right? My big rectangle, oh my gosh, should be the area of my big rectangle. So the area of my big rectangle, right, because we're dealing with a rectangle, is always going to be my length times my width, right? And so the length of my big rectangle, because I always write my knowns and my unknowns, and this is going to help later on too, my length is this 65 feet down here. So 65 feet. I swear I have nicer writing when I'm not writing on here. And then my width is this 360 feet here. I'm going to erase that so it doesn't look terrible, but just wanted you to see. Right, so 360 feet. Okay. And then what we have to do is we have to plug the information we just found into the equation, right? So I have my area equals, okay, this is really bugging me how I can't write nicely. My area equals 65 feet times 360 feet, which gives me, let me just scroll down to find my information that I already have written out, 23,400 feet squared, right? Because feet times feet is squared. So then I'm just going to box it. Perfect. So we've now found the area of our big rectangle. So the other 2 areas that we need to find are the garden and the house, right? So we're going to take a look at the garden first, and I'm going to do the garden in green. Okay, so we're going to do, let me scroll down a little bit. Number 2 is the area of the garden, right? And because the area of the garden right now, it's still a rectangle, we're going to use the same formula that we did for the big rectangle. So I'm going to do my length times my width. So my length of my garden, right? We have the garden up here. So my length of the garden, I always write my knowns and unknowns, sorry. My length of my garden is going to be 50 feet, right? So I have my length is 50 feet. My width of that garden, right? So my width of the garden is going to be 80 feet. So I can now plug the information I just found into my equation. So I have my area equals my length, which is 50 feet, by my 80 feet, right, which is my width. And I'm going to get 4,000 feet squared. Okay, so I've now found the area of all of this whole big rectangle. I found the area of my garden. So the last thing I need to do is find the area of my house. Okay, so the area of my house, it's also still a rectangle, so I get to use the same thing. So I'm going to do the area of my house, which equals my length times my width, right? And my length of the house, let's go scroll back up and take a look. My length of this house is going to be, where is it? 45 feet, and my width is going to be 20. So my length equals 45, come on, 45 feet. Okay, 45 feet. And my width is going to be, I think we said 20 feet, right? 20 feet. So then I'm going to take this and I'm going to plug it into my equation. So my area equals my length, which is 45 feet, times my 20 feet, which equals 900 feet squared. Perfect. Okay, so I've done step 1, which was break apart shapes into shapes I already know. My step 2 was to find the area of each of these shapes. So we've done both of those. Now our step 3 is to either add or subtract the areas together to get the the total composite figure area. That was terrible English on my part, but that's okay. Okay, so what we need to do now is, because we only need the green, let me scroll up here, because we only need this green area, right? So let me just erase all of this so you guys can see we only need the green area, right? What we need to do is we need to take the big rectangle and minus, sorry, I got hiccups, and minus the garden and the house areas, because we don't want to mow the garden and we definitely don't want to mow the house. Unsure how that would even work, but we don't want to do either of those things. So we need to take this big rectangle area and minus those two from it, okay? Because the composite shape is like this weird looking thing that we want instead. So what I'm going to do, I don't remember if I changed this, but I'm going to now. So I'm going to take so I want the area that we want to mow totally equals my area of my big rectangle minus the area of my garden minus the area of my house, right? So the total area that we found was 23,400 feet. So I would go 23,000, my area total equals 23,400 feet squared. And then minus the area of my garden, which was 4,000 feet squared. Oh, okay. 4,000 feet squared minus the area of my house, which is 900 feet squared. Perfect. So when I do that mathing, I end up getting 18,500 feet squared, right? So that's the total area that I want to mow. Perfect. So we've done the 3 steps that take us to this point. Now, because it's asking us in this question, okay. No, didn't want that, but that's fine. We're just going to deal with it. Because it's asking us, sorry, hang on. Because it's asking us the price that we need in meters squared, what we need to do next is convert, right? Because we're looking for a total price, but we only have feet squared right now. So we actually need to change it into meters squared. And that's where this came in, right? I don't remember if this is on your conversion chart. If not, what you can do is always change the 1 foot. You can Google it, but you can change the 1 foot. So how we can do this is normally I think on your conversion chart it says, sometimes I ramble and I don't make a whole lot of sense, so just give me a second. Okay. So how we get this from your conversion chart, if it says, I think it says 1 foot, I'm just going to write conversion up here. Conversion. So we have 1 foot equals, where is it? 0.3048 meters. Right? So that's the conversion I think that we have on our conversion chart. So for us to be able to get this into feet squared and meters squared, what we can do is we can actually take this and we can go 1 foot times 1 foot is going to give me 1 foot squared, right? Because feet times feet is going to give me 1 foot squared. So then what I need to do is I need to multiply this by itself, right? So I have to go 0.3048 meters times 0.3048 meters, which gives me, or 0.9, what was it? Oh no, that's supposed to be 0.9. 0.09, I have this written down, 29 meters squared. So that's where that conversion came from. So when we're converting this, right, we have to do our conversions that we learned in lesson 1. So to do that, we take our 18,500 feet squared and then we do this multiply sign, and we put whatever we want to change it to, right? We want to change it to meters squared, so this one. So I'm going to put that on the top, 0.0929 meters squared, and my 1 foot squared on the bottom. So 1 foot squared, right? And this is going to give me the conversion that I want. So this is going to be able to cross out the feet squared, and I'm going to end with meters squared. So I do 18,500 times 0.0929 meters squared, and then divided by 1. So this ends up giving me, so this here equals 1,718.65 meters squared. So we've now changed our green grass that we found. Okay, I keep making this worse and worse and worse. We're going to scroll that back over. So we now found this green grass, how much that is in meters squared. So the last step that we need to do, right, because we've done all the conversions that we need to do, all we need to do is figure out how much this is going to cost. And we know, right, we know that it's going to cost us 2 cents per meter squared. So what we get to do is take what we just found. I'm going to do you in black. So what we just found, right, so I'm going to take my 17, why did you not change colors? Let me just, so we're going to take what we just found. So our 1,718 or 18, I can't even English. Okay, 1,718.65 meters squared, and then we times it by how much it's going to cost per meter squared, right? So I'm going to times it by my 0.02 meters, $2, $0.02 per meters squared. So what this does is it allows us to, that was a terrible drawing or representation, per meter squared, right? And so because this is per meter squared, these get to cross out, and it's going to tell me how much it actually is. So I'm going to do 1,718.65 times 0.02, which is going to give me $34.37. So that right there is going to be how much it costs to mow that lawn. Now, because this is a word equation, right? If we scroll up, this is a word equation. So what I have to do is my therefore statement, right? So therefore, it will cost, this is going to be terrible writing, I'm going to apologize. It will cost $34.37 to mow this lawn. Perfect. Okay, so we did all of the steps that we needed to do for this question, right? We did our step one, we broke it apart into shapes we knew. We found the area of each of these shapes, right? We found the area of the big rectangle, the garden, and the house. And then our step 3 was to add or subtract the areas together to get the total area of the composite figure, right? So this green part here. So what we had to do, because we didn't want to do the garden and we didn't want to mow the house, we had to take the full area and minus the garden, minus the house to get what we want to mow. And then from there, what we were able to do, right, we were able to get that amount in feet squared. So we now had to change, we had to convert from feet squared to meters squared because we knew the price in meters, like per meter squared. So we converted into meters squared, and then we were able to multiply it by the price it was per meter squared to get our total. And then we did not forget to write our therefore statement because this is important. So always word equations, write your therefore statement, okay? So that is everything for this lesson. So what I want you guys to do is you do have the practice homework questions up already. I want you to do page 11, question number 5 to 9, and question 12 as well, okay? If you have any questions, please let me know. do not hesitate to reach out, and I'm here to help.